Welcome to the KTA Coding Inspection Instrument Training Series. This is one of many modules that are available to you. You can find all the modules at kta.com or paintsquare.com. This module covers the use of the Testex Press-A-Film tape and spring micrometer. The tape complies with Method C of ASTM D4417. The tape is used to create a reverse replica of the surface profile that is measured with a spring micrometer. The profile is important because you want to make sure it complies with the specification requirements or the manufacturer's instructions prior to applying a protective coating to make sure it's rough enough or not too rough. After measuring the tape, you can also keep the tape as a permanent record of the profile achieved. Before I demonstrate it, I want to describe the tape. There are a number of tapes available. I'll give you the range of those in a moment. But first, the tape itself. We peel the wax paper backing off the back, and it consists of a 2 mil thick film of Mylar in this circle. The back side of that Mylar is an emulsion of microscopic bubbles. When I put the tape on the surface, emulsion side down, and rub the back with a burnishing tool, I'm actually breaking the emulsion, the bubbles, by the peaks of the profile, creating an exact reverse replica of that profile that is then attached to that 2 mil thick film of Mylar. The total is measured with the micrometer. You subtract the thickness of the Mylar to get the depth of the profile. There are 3 tapes available depending on the profile depth you will be measuring. The coarse tape is good for profiles from 0.8 to 2.5 mils. The extra coarse is good for profiles from 1.5 to 4.5 mils. And the extra coarse plus tape is good for profiles from 4 to 5 mils. Now note the overlap between the tapes. For example, the overlap between the coarse tape and the extra coarse is 1.5 to 2.5 mils. If you run a test with the extra coarse tape, for example, you get a reading of less than 1.5 mils. Go ahead and use that value because that's not in the overlap range. If you use the extra coarse tape and get a reading greater than 2.5 mils, use that value. It's not in the overlap. But if I use the extra coarse tape and get a reading between 1.5 and 2.5, because it's the overlap, I need to use the coarse tape and take a reading with it and average the two. And this bar at the bottom of each piece of tape reminds you of that. To take a reading, I'm using the extra coarse tape because I think that's what the profile range will be. I peel off the backing. Remember the emulsion. I place it emulsion side down, and often it's easier just to bend an edge here so that the tape doesn't stick. You can get it off. Also, when you're dealing on blast clean steel, you would use gloves or something to avoid contaminating with your hands. Once it's in place, rub the back of the emulsion with the burnishing tool until it turns uniformly gray. I've now created a reverse replica of the profile, you see it there, attached to the back of that 2 mil thick film of Mylar. Now I want to measure the thickness of the tape, which will tell me the depth of the profile. Here I use the spring-loaded micrometer. I've got it set on 0. Put the tape between the anvils. That's reading 5.9. Another reading, 5.85, 5.85. So let's say it's 5.8 just for round numbers. I subtract the 2 mils of Mylar, which means the profile depth is 3.8 mils. 3.8 is within the range of the tape, so I know it's a good reading. It's also outside of that overlap area, so I know that this profile is in fact 3.8 mils. And that's all there is to it. And again, other modules are available for your viewing at kta.com or paintsquare.com.